Hi. The second and last presentation in the Combinational Design playlist addresses the important task of design verification. In other words, is the circuit that we designed fully compliant with the specification that guided its development, and namely with the functional requirements listed at the start? At the end, I expect that you will be able to explain what is design verification and how it can be achieved by simulation, and also that you will be able to create simulation source files in Vivado. Accordingly, this presentation comprises the two parts shown here, design verification, followed by the creation of simulation source files, or test benches as they are also called. Let's then start with simulation for design verification. Simply stated, design verification consists of checking that our design is fully compliant with the specification that guided its development. This is much easier said than done in the case of large complex circuits, which is basically the case of any circuit implemented into an FPGA. Notice also that exhaustive verification, checking that the circuit responds correctly under every possible operating conditions, may simply be impossible due to the number of input combinations. How many input patterns would you need for a 32-bit ALU? It is, however, possible to carry out limited design verification through simulation, and Vivado offers various simulation alternatives for this purpose. The simplest of them is behavioral simulation, where all timing aspects are ignored. This is the type of simulation that we will consider in this introductory course. So the question becomes, how can you create a simulation source file in Vivado to check if your design behaves as expected? It turns out that the simulation source file is simply another VHDL file comprising the same three sections that we are already familiar with: library, entity, and architecture. Moreover, it uses a subset of the same statements that we already know, and particularly the process statement. So answering this question is actually simpler than you might have expected. Let's look at the example using the omnipresent 2-to-4 decoder circuit. You have recognized the data flow description model, right? So how can the process statement be used to create a simulation source file? What you see here is the simulation source file used for design verification in the case of the 2-to-4 decoder. You may have noticed the library, entity, and architecture sections on the left column, but let's have a closer look at each column. The left column contains the library and entity sections and the beginning of the architecture section. Particularly worth noticing is that the entity declaration is empty, since the test bench is a module created solely to provide inputs to the circuit under test and to monitor its responses, and as such it does not interact with the external world. You should notice also that the architecture section starts by a component declaration, which we will put to use in soon. The middle column instantiates the decoder as a unit under test and allocates its inputs and outputs to the equivalent port names indicated in the component declaration. But what is more important to notice is the process statement. To start with, notice that it does not have a sensitivity list. This means that the process triggers immediately, and it will suspend its execution for 30 nanoseconds when it reaches the wait statement. The initial three statements will take effect when the wait statement is reached, so what we expect to see is the three inputs set to 0 at the beginning and remaining on that logic level for 30 nanoseconds. The right column concludes the description of the process statement, and as you can see, it drives the 4 possible logic combinations to the in1 and in0 inputs, while holding the enable input at 1. The process will repeat indefinitely during the simulation period specified in Vivado. How could you stop it from repeating itself after the first execution? So now you understand how these waveforms that you have seen before were generated. All the outputs will be low while enable is 0, and each output will be activated in sequence as we go through the various logic combinations at the input ports in 1 and in 0. You may wish to retain this summary in your mind now that we are about to conclude this module. The simulation source file uses a structural modeling style to instantiate the unit to be tested, and a process statement encloses alternate sequential signal assignments and wait statements to progress through the sequence of input patterns. And this is where we stop in terms of combinational circuit design. Thanks for your attention.